All right, so we have quantitative data, so our sample statistic here is X bar, and so if we go back on that previous output screen, our value of X bar was 145.4, and I guess we could put like points or something here for IQ score. They didn't give us any units for that, but just to remind ourselves that quantitative data typically does have units attached to it. And then our standardized test statistic here, we're going to use a t-score in this case. And again, these formulas also on your cheat sheet. You do not need to memorize these. So in the numerator we have X bar minus mu 0. So again, we're trying to figure out how big that gap is. In statistics, we measure size of those gaps by seeing how many standard deviations fit in that gap. So we're going to divide that by S over root n. So that gives us 145.4 minus 100 in the numerator. And in the denominator, we're going to get 29.2744 over the square root of 20, which again, we're just going to cheat and copy that off of, just copy off the output screen. So again, I have you set this formula up because I do want you to understand what actually goes into the making of that. So sometimes when we conclude in the end and we say there is significant evidence, sometimes students are confused and think, well, we could have made a mistake because the sample was so small, because it's only 20 here. But you need to recognize that in this t-score, the sample size is taken into consideration. So if we find we have an unusually high value or an unusually low value, it's taking into account that we have a small sample size, and it's considered there's enough evidence in just 20 data points to consider it to be unusual. Okay, where if we just write down t is approximately 6.94, we kind of lose sight of the fact that it's taking the standard deviation and the sample size into consideration here when it's trying to determine if this 145.4 is unusually high or not. Okay. All right, so this test statistic means that the observed sample mean is 6.94 standard deviations above, since this one came out positive, the claimed population mean. Okay, so that's way far away from the claim if we understand standard deviations. But again, people understand probabilities much better, so we're going to look at a p-value. So again, the next letter in Phantoms is O for obtain a p-value. And again, we're going to draw a picture to try to make sense out of all of these numbers. So again, if we go back to that view screen, our p-value here starts out 6.52. Okay, but again, p and p-value stands for probability, which means it's a number between 0 and 1. So it can't be 6.52. So when we see 6.52, that tells us to look to the end of the line, and we see this e minus 7, which means this is the exponent on a base 10, so 10 to the negative 7. So basically it's this number, and we're going to divide it by 10 7 times over. Okay, so our p-value here is approximately 6.52 times 10 to the negative 7. Okay, so remember, this means we're going to take 6.52 and divide it by 10 7 times, so we would get this number. Okay. Now, you can leave it in scientific notation, 6.52 times 10 to the negative 7, but I've written it out just so that you, in case you don't know what that notation means, that it means we have a really teeny tiny p-value. All right, so as we draw a picture to help all these numbers make sense, again, we're dealing with the distribution of X bar. It has a t distribution, and we're using t-scores. So again, it's still a bell-shaped curve. We're going to put the claimed value here again in the center. So they claim mu is 100, so we would expect to see a value of X bar near 100. The t-score on center would be 0. What we actually observed in the data set, though, was 145.4. Okay, so a lot bigger than 100, and the t-score tells us, again, the corresponding t-score there was 6.94. Right tail test, so the area in the right tail, which basically we can't see any because it's so tiny, so rounded to 4 decimal places, that is about 0. And so again, that p-value, to make a decision, we have to compare to alpha, and in this case that was again 0.05. So in this case, our p-value, 0.0000, when we rounded it, is definitely less than or equal to 0.05. Okay, which means this 145.4 is an unusually high value of x bar, which means we don't believe mu of 100 is true. We think the parameter is shifted to the right, that it's higher than that. So in step 7, M for make a decision, we're going to say since this p-value is less than or equal to our alpha value of 0.05, we are going to reject the null hypothesis H sub 0. So our last step here, S, is to state the conclusion then in context. And so again, if we reject HO, that means there is significant evidence to conclude HA. So in this case, we're going to say there is significant evidence to conclude and again, we just translate HA into words, and so mu was the mean IQ score for all famous people. So the mean IQ score for all famous people exceeds, or is greater than, means the same thing, exceeds 100. So again, we only looked at data of 20, but the data in just those 20 data points was so overwhelming that we could conclude that we think it's true for all. Okay, that the mean IQ score for all famous people would also exceed 100.